we'll be looking at striking a moving object by two different sports. One is baseball and the other one will be table tennis. First, let's look at the baseball batting. And in 1954, where the motion analysis system was not available, the researcher Hubbard and Sang did analyze the frame by frame of the eye position of the batter, and what they found was the eye, the position of the eye, were not tracking the ball at the contact point, which means the batter tracked the ball only to a point. Well, some famous baseball player claimed that they could actually see the ball at the point of contact, but it was not the case for general population. Well, they actually analyzed the famous baseball player at that time, but they couldn't really find the eye position which tracked the ball at the contact point. What they additionally found out was the stepping forward motion was synchronized with the release of the ball from the pitcher, and also the duration of the swing was consistent across the batter. Step forward was coincidental with the ball release of the ball, but actual initiation of the swing occurred using tau information. Time to contact tau information. And this one can be backed up by these researchers. In that 1984, they could analyze the eye movement with the motion of the batting, so they could actually analyze in depth. They compare the major leaguers and versus college baseball players, and interestingly, college players track the ball to a point about 9 feet, but the major leaguers could track the ball up to 5.5 feet. And the head motion or the posture was very consistent compared to college baseball players. So they explain the reason why we can only track the ball to a point is that when this is our head and this is our trunk, so let's say we have a bat in our hand, so it's looking at from the top end view, this baseball cap, and let's say this ball is projected from the pitcher, so the ball is coming this way, right? So when they look at the ball, so the angle, so the ball is, let's assume the ball is coming at constant horizontal velocity, so let's say within 10 milliseconds, well no, it's not, 10 milliseconds, the ball traveled from this to this distance. So they can actually track the ball by using their angle. Let's say this is theta, the projection angle from their eye. So the angular velocity of that ball would be this theta divided by 10 milliseconds. When the ball is near the batter, let's say at this point of time, in the same amount of time, the ball will travel the same distance. So 10 milliseconds. So So ball will exactly travel the same distance as this point. But what you can see is the theta between this point and that point. So the difference between the angle. So it's let's say theta. This different theta divided by 10 milliseconds is greater than this theta divided by 10 milliseconds. And Bahil and Lauritz say at the contact of the ball, this angular velocity reaches about 500 degrees per second. That's really fast one. And the human limitation to track the angular velocity is about 70 degrees per second. So that's normal population, and that's the ball velocity at the contact. So because of this angle difference, that is the fundamental reason why we cannot track the ball at the contact point, because it exceeds the normal tracking speed of our visual system. But with the practice, the major leaguers were able to track up to 5.5 feet. So there's a contact point. Let's say this is the contact point. So up to 5.5 feet, the leaguers could track the ball. And from that, rest of the remaining trajectory, all the batters have to estimate the time to contact and do the action in accordance to that information. In other words, the major leaguers had faster, smooth pursuit movement of the eye. Than the novice. Because of smooth pursuit eye movement, faster smooth eye movement, they could overcome the normal tracking angular velocity and track the ball up to 5.5 feet. And the researchers also mentioned about some of the players they claim that actually can see the ball at the contact with the bat, and they assume that it's probably they have kind of unique way to incorporate the reflex-like eye movement with that instance. So that reflex-like eye movement is also known as saccades, and the saccades is usually very fast. It's faster than smooth pursuit eye movement, and it's very rapid. So if they were to train the saccadic eye movement, they could actually track the ball to some point and jump out and with the saccade and actually able to see the contact of the ball. But it's not actually proven with experimental procedures. It's just assumption that to explain some of the players who could actually see the contact of the ball. So if they claim they could see the ball, and if they're true, it's likely that they use the saccadic eye movement instead of our normal pursuit, smooth pursuit eye movement.